So let's solve a problem which appeared in JEE Main 2017. And this problem states that let omega be a complex number such that 2ω+1 is z, um, a complex number again, and z is actually equal to square root of -3. And then if this determinant is actually equal to k, 3k, then we have to find the value of k. So let's look at this. What is this omega gonna be? So omega is going to be, we can say this omega is going to be z minus 1 upon 2. So what is going to be my z? Z is this. Actually, I could write it as the square root of 3i. So this is square root of 3i minus 1 upon 2. So this is a cube root of unity. If I write it as this form, like we remember it, minus 1 plus root 3i by 2. And this is what is my omega. So I know that omega square also would be actually minus 1 minus root 3i upon 2. And then there will be other properties as well. We should remember that 1 plus omega square actually would be actually equal to 0. And then omega cube will be actually equal to 1, right? So we have to be careful. Sometimes they try to flip the sign also. So in this case, it is simply the same omega, which is a cube root of unity. So these two relations we should know. So using this, we can actually simplify my determinant, and we can write this as 1, 1, and 1. And then we can write this as, this is 1, it's fine. But this is minus 1 minus omega square. So if I send this to the side, minus 1 minus omega square actually will become equal to omega. So I could write this as omega. Now, this could be written as omega square, and then this will be omega square itself. But omega raised to the power 7 can be written as omega. Why? Because omega raised to the power 7 could be written as omega cube into omega cube, right? Into omega to the power 1, right? And this is actually 1, this is 1. So 1 into 1 into omega. So this will be omega, right? So this is simple now. Now we can either directly expand it or use some property. So I'll just expand it. So what will happen? This will 1 and this will become omega square minus omega raised to the power 4. And then this will become minus 1. And this will become omega minus omega square. And then this will become plus 1. And then this will become omega square minus omega. So what do we get finally here? So again, let's try simplifying this. So this will become omega square, but I can write omega raised to the power 4 as omega, because omega raised to the power 4 could be written as omega cube into omega. So I could write this as omega. Now minus sign goes inside. This will again become omega square minus omega. And then finally this as well. This is also omega square minus omega, right? So all in all, what we have got is 3 times omega square minus omega. So actually, this is actually equal to 3k, right? So from here, what we get is k is actually omega square minus omega. We'll substitute whatever is omega square is. So my omega square is minus 1 minus root 3i by 2, while my omega is minus 1 plus root 3i by 2, right? So as you can see here, we can just write it again. This will be minus 1 by 2 minus root 3i by 2, and this will be plus 1 by 2, and then minus root 3i by 2. Okay, so this 1 by 2 and minus 1 by 2 would cancel out, right? So now this is what is my omega, right, which is having the plus sign. So what I got here is basically minus root 3i by 2 and minus root 3i by 2, which is actually minus root 3i itself. Now, this is root 3i was nothing but z itself, right? So this was nothing but root 3i iota, right? So now this is actually come out to be minus z. So yeah, this is what will be our answer, minus z, right? If you have any questions about this or any doubts, please do ask me in the comment section below, and I'll be happy to answer your queries. Thank you so much for watching this video. Have a good day.